So, welcome everyone, and this is the third lecture of Fundamentals of Game Development. So on this new lecture, we are talking about game engines. What they are, what sort of things you can do with them. I'll show you a couple of examples of what constitutes a game engine, and you can get started. Of course, because this is no longer an introductory course to programming, this is a master's level course and you should already know programming work. We are not going to be talking about what is a variable and what is a data type and these sort of things, but I will be showing you some basic functionalities of game engines and what different types of game engines actually do. So hopefully you will find this information useful on your own project and can get started on your own development work. But let's move onwards. So, like said, fundamentals of game development and the new third lecture on game engines. So the course is now at midpoint, and this time we take a look at the last things you need to know for making your own game. And on the second period we will be having a visiting lecturer and also talking more about the theoretical stuff or the management point of view when comparing software industry, the games industry against each other. So, game engines. Nothing more, nothing less, but game engines. This is what we are talking about today. This I showed you earlier. So if you want to make games, and if you want to make commercial games, or if you want to make a career out of games, or if you want to make a game studio or found one, you basically need a computer, developer, and place to sit. And that's your game studio if necessary. Of course, if we go into more details, you will also going to be needing game designers and graphics animation artists to draw your game. You need programmers to do development work, and of course how much programmers you need depends on how much complexity you have on the game. Also test audiences, normal programming tools, version control, code editors, and also the game engine or the framework or which you will be using to run the game. Of course, on this list of things, game engine isn't on the top 3. In fact, it's not even top 5, but it's one of the actually most important pieces of software your organization is ever going to be needing. If we take a look into another slide I showed you last week, the tools in different stages of software development, you will notice that whether we are talking about pre-production phase or production phase, when we are actually doing the game, pre-production meaning that we are of course doing prototypes and doing designs, seeing what might work and what not. Actually, all these mention the game engine some way. So in the design or prototyping, we use game engine. In the development, we use game engine. In the implementation, our development tools are game engine in the design phase and the implementation phase, and that's because the game engines are huge software or, well, even small framework, which usually handle very crucial things. They are responsible for getting your graphics or 3D models into the screen. They are responsible for managing your camera if you are doing 3D, or moving your camera when you are doing 2D. They do collision detection, they do scripting work, they launch animations, they launch sound effects, they manage music. Basically everything that happens to games is usually done by some form of game engine. So overall, it's safe to say that the game engine is the most crucial piece of software the game studio has. Of course, what game engine you want to use sometimes differs based on what type of games you are making, because the game engines are not all the same. Actually, on this lecture I will be giving you examples on the large-scale development environment style of engines, on the platform-dependent engines, on the genre-dependent engines, and also if you want to go completely without one. because the game engines are running the show more or less, you need to select one, or you really need to select one and start to do development work with that. If you are overhauling or changing game engines, you are usually from the viewpoint of development starting from almost scratch. So game engines, they vary, or they have different scopes. This I already said, from the auxiliary libraries to full development suites, but they also differ between other things like platforms, because not all engines support all delivery platforms, or genres, because some game engines like RPG Maker are specialized to different type of genres. RPG engine Maker surprisingly makes or is intended for role-playing games, or licensing if they are for commercial use or open source tools. Are they available as service, or are they a product you have to purchase? How can you acquire one? Do you have to pay upfront, or can you access one on a lease sort of way, that when you are making so much money, then you have to pay something? Basically, all these things affect on what sort of game engines are available for you. And finally, of course, the accessibility. So what type of development work your game engine expects? Does it require or expect you to be able to do full-scale programming, or all your developers or level designers or people involved with the creation of your assets, are they required to do programming work, or are they more like constructor sets, which allows your team to have programmers to do scripting work, graphical artists to add assets, and the level designers to do the levels themselves by adding objects here and there and populating the world with different things. Of course, there's no right or wrong answer here, but it's just that the game engines have different philosophies on how they want to offer things. So, to explore what these philosophies are, what sort of difference there are in game engines, I have compiled a couple of examples on which I'm going to be talking about what game engines do and what sort of features are usual, and what sort of common themes or things there are on the different types of game engines. Like said earlier, and I will be saying this again when I'm doing the examples, this is not intended for you to understand how programming work is done, or how if-else variables are used in game engines, but to give you as a developer ideas, or understand the concepts, what the game engine is for, and how it, for example, manages the project assets, or how it builds up the logistics chain that finally comes out from your pile of things like graphics, sound effects, animations as a complete game. So let's move on to these examples. I'll explain you on the way what things you see and what sort of things you get to know. All examples are from freely available game engine tutorials or self-made, and most of these self-made things are also actually available on our game research group's old website, which you can find from the URL of or the address bar of one of the examples. Keep an eye out on that if you want to test out the rest of the example games. Okay, so if we are talking about game engines and what to do with them, we should obviously start with Unity 3D, because out of these game engines I'm using today as an example, it's definitely the most complex and at the same time most extendable one. So what I have here is the first-person shooter tutorial project, which you can all find on your own Unity installations. Right now we are loaded to the scene intro menu, and as you can see, there's basically nothing else here than just the startup screen. And if I run the project, we will get to the start screen, And when we click play, we can use the demonstration mode to test stuff. Of course, we can move all the way like we usually do, forward, backwards, left, right, even jump. And we can use our mouse to look around, and we have a gun we can use to shoot things. Okay, so on this easy tutorial, the idea is just to shoot all the enemies. There was that one bot there, and there's the second enemy downstairs. Let's go meet that one, and I think it's here. It's that turret, which is very, very well armed. So basically, our task is to just kill that. So I'll just there. So we won the level, and we also completed the game. So now we are on the win menu and yet another view screen. So of course this is a entire game compacted into really small things. You have the start screen, you have the level, and you have the end screen. So on the Unity 3D we are talking about scenes when we are talking about different levels and transitions and these sort of things. So now we are on the intro menu like we were before, but because we run the preview build, it meant that the game played along, and it actually transitioned us to the main scene and finally to the win scene. If we go to the main scene here, we actually see that the UE overlay is here on the space, and the actual level is right down here far below us. Why this works and why this doesn't look very weird is a trick of the sort of viewpoints and camera overlays and stuff like that. If we look at the preview view, we can see that we are now on the normal level, and if we run this on a play with the play button, we actually get to start at the start of the scene. So what's going on and what exactly makes this Unity 3D tick, and how are these game engines in general developed, and well, what sort of things they usually do? Okay, since this is not a introduction to programming course, although this is an introduction to game development course, I'm not going to go into the programming stuff like what are variables and how I do for loops and stuff like that. But I'm going to go through this Unity project and show you what sort of things they usually are, and then of course compare it to other solutions and talk about also frameworks which are a sort of game engines in a sense that they provide services but are not actual editors. So first of all, the important thing to understand with the Unity is that this is actually an entire tool to develop everything. The entire project is here, and you can connect this to the version control. So all the assets, audio files, all the sound effects and the background music and stuff like that, they should be here. All the scenes are here, these levels, and all the different 3D models are also here. So when you design something with the 3D tool, then you can put them as a prefab and then give them a texture and put them at your scene. When you put something to your scene, you get things to this hierarchy here. So for example, on this example game, which we can see here, we have some things mentioned here. For example, the player character is this one, and it has a camera attached to it. And as you can see, or well, you can at least somewhat see it, the player character is actually a invisible capsule which is running around at a certain height. Because we are playing a first-person shooter game, we don't actually have to exist in the map itself. But we also have here on the scene is that all these enemies, the turret at the basement and also the hoverbot here, they have their models and they have their existing well effects and all the other things mentioned. So basically we are playing around with a set of tools. For example, if we want to put this
turret into another position, we can move it around on the map, and that should also update to the game or when we are doing on the preview mode. Also, if we want to use enemies from predefined places, we can simply duplicate, for example, one enemy and make several of them. Of course, I think that I accidentally deleted that one, so let's try it again. So if I duplicate the enemy and put several of them here, this actually also immediately shows on the game itself. And of course, what is interesting actually is that because we have scripts somewhere else which just calculate the types of enemies, that's okay, we have a certain amount of enemies. If we start the game now, instead of one robot, we have several of them, and our script actually updates the information. So basically, if we are doing things correctly, we can focus on doing the design work. So okay, so when we have these objects here, then we can add different features to them. If we are adding AI to them, we can add them as an item or module to this object. We can add audio sources, meaning that if the enemy gets closer to us, we get to see how it we get to hear it when it approaches us. And of course, if we want to alter how the enemy behaves, we can include artificial intelligence to those things. For example, if we want to take a look at the player character, we have several different things here. These are attributes from the source code. So when we go to check the scripts, for example, here, and we get the actual player character, we can get where is it? There we have it. So we have here a large number of code. Of course, if this was a other screen capturing tool than this normal record, I could show it to you. But because I cannot load editor right now, I'll just have to show you that all these information we can edit in the Unity tool is actually parsed from the source code, which is more or less here. For example, here we define how the player acts, or what happens when player does different things, and what sort of information the player, how the player behaves when we press something, or how the player acts when we do different activities. For example, these things are then transferred to the player character here. So basically, every time we include a script into the character, we can define a behavior for the character. And for example, one interesting thing we could do here, for example, is about the jump force. So if we do the setting 9, it means that we are doing this normal, pretty low-key jump. Of course, if we increase this to something else, like 90, we can immediately change the behavior of our character, and actually we can do a sort of wall hack by actually jumping around the place, doing very interesting activities. Of course, jumping force 90 doesn't actually make any sense on this game, but this also allows us to alter the behavior of how different characters and different features work. Similar functionality is actually related to also the map itself. So basically we have drawn the map, or well, the tutorial people who made this tutorial have drawn the map here. And everything actually is something that we can take as an object and move around, or scale around, but let's just move things around. So if I want to make a shortcut for my character, of course I can just put this somewhere else, and then try to walk the gap or jump the gap this time. And this immediately affects how that level works. So this also allows us to have two different people. The people who do the programming work to set up the game itself and create the characters and define the AI, and also people who do the 3D graphics, create the animations and do the level design, because basically what we do here with the level design is basically or something very close to interior design. And if we have a good game engine, this you can also see that actually doing a prototyping work or doing some quick tests on what works and what doesn't is actually fairly easy when we get some basic characters or basic things set up. For example, with this tutorial, we already have one level, two different types of enemies, a fully functional physics engine, and all the other things set up. So basically, by adding new levels and adding transitions, not to the end screen, but another level, we could actually build a narrative and get started with a game. So this is how a game engine actually works. It gives us the possibility to use or create levels, create behavior, alter the behavior, create scripts, add sound effects, add backgrounds, add textures or change textures with fairly easy and approachable approach. Of course, here this actually has a different type of a this is a different type of a tool, floor tile, than the rest of them, and that's actually, interestingly enough, it's completely separate thing on that level. We could build that up as an elevator or use it as a platform for jump back or whatever, but basically the fundamentals are here. So instead of making everything by yourself, the game engine provides us with the tools we can use when we have made the basic fundamental things, like created the player character, created the enemies, created the 3D models, their animations and the level textures. Then we can start setting up the actual game and defining the behavior and what happens when the player progresses through the levels. And that's the short version of it. And of course, other things besides project level management or scene level management or ability to do quick previews or test runs with the games or include pre-made aspects from the asset store. This game and the connection to the code editor, this allows us to have different functionalities and at the end use a build settings to create and release the game on the platform we want. So what scenes to include, to what platform, and then build it. And if we were releasing something as a commercial tool or commercial product or commercial game, then just upload it to the market or upload it to the test market and see how it does, and then release it as a fully available product in the App Store or somewhere else. So that's the basic gist of how game engines work. That being said, Unity is fairly large scale and, well, huge scale really, and it's one of the most used game engines, but it's also one of the most complex game engines, and it has the approach where we actually have to do some programming work, have to do the programming stuff with C# to get these behaviors and scripts and these sort of things done. While we can do many things without programming, we still need to do programming. So let's look at something else that's one step away from having to do programming work while developing games. Okay, so let's start again by showing you the actual game. So this is a fire jump. This is a tutorial game from the Game Maker Studio 2, which is a game engine focusing heavily on the 2D games, and it's actually very good at them, and it has been running for a long time. But on this tutorial game, we again have all the basic functionalities. We have the main screen, and if we start the game, we start to climb up into the building, and of course if we fire, our character runs off, and we can start from the replay menu the mission again. If we happen upon people living in the building, then we will have possibility to save them, and with the space bar you can shoot at foam to save people building. Of course, this being a never-ending game, basically the hate you get is basically the amount of scores you can get, and the best hate is something that the game saves for you. Anyway, a complete game and full game in a sense that everything you need to have is here. You have the sound effects, you have the character, you have the game level, you have continuous loop, and you have randomly generated map so that all the different game sessions are a bit different. So all in all, this is a full game developed with a game engine. So what makes this game engine different from the Unity we saw last? So let's go check out the inside part of the Game Maker Studio. So like said, the Game Maker and to a large extent the Unreal game engine, which is the second large game engine developer or provider besides Unity, the Game Maker has a bit different approach into how the games are delivered. First of all, the scenes are actually delivered as rooms. The Game Maker supports 2D games, so basically all these rooms or all these levels are more or less paintings where we just drop in different objects or models as sprites, so to say. And we have this one for the level, basic setup of the level, and this one for the basic setup of the startup and end screen. Of course, you can see that the buttons aren't labeled because the buttons change information regarding what we are actually doing. But the interesting things are about how the programming works, because this approach tries to minimize or avoid having the player to do actual programming work. We have extensive trees of defining what sort of things happen when different things are done. For example, here we have the object player. And the player object, which is the fireman jumping up, we have different sort of events what happens. So when we start the game, when we start to move, when we stop to move, what happens when we press left on the keyboard, what happens when we press right, what happens when we press the space bar, what happens when we interact with the fire, with the object, and all the other things. So we and for example, if we press left, we can see that the instance is transformed minus 15 values because it moves left. Similarly, if we go right, we add 15 because we are going right. So basically, we are moving the player character on the room or on the level based on these key press events. Also, when we press space, we create foam and we play an audio byte. Of course, similarly to what Unity does, all the objects or items which are in the project or in the game are here. And the different layers and how the camera shows different things are defined on the other parts. But the interesting part is that everything is defined so that we have objects. This is the player, this is the street or the level. These are these different objects like the foam we create when we press the space bar. It's defined here, and what happens when it goes to the level or is created to the level, we actually have events how that handles. So basically what we have here is a defined very delicate state machine. Instead of writing code, we are defining a state machine which runs the game and creates the game logic. And this of course means that it's easier to get started, but of course means that we are limited to the options that the game engine gives us. And of course, while we have several different options, and usually this is not a problem, there are some differences. For example, if we teach or if we start using the game maker or approaches where the game engine is using a state machine, then we don't necessarily need to teach programming work that much. But on the other hand, if we use Unity and the systems which are script driven or require us to do programming work, it means that our developers also need to do much work with the C# and these sort of things to get started. So it's basically a different mindset or starting point for the development, but both are as valid as each other. For example, we know that the Unity is programming oriented, at least to some degree. It does allow you to do editing work without having to do programming work. But the Game Maker and Unreal are more the state machine approaches, where we can add assets and add events to them and make design what happens when things are done with the visual editors like demonstrated here. Of course, some more specialist game engines like RPG Maker also use similar approach like this, but this time we are not going to those specialist engines. They are designed so that they support making that genre of games very well. Game Maker still maintains that it's a 2D game engine, but it still allows different types of games. RPG Maker, for example, allows us to do role-playing games very well, old-style, old-fashioned games, and the Unreal Engine and the Unity Engine, of course, are the more whatever you want to do with them, whether it's AR, VR, 3D, 2D or 3D games, you can do the development with them. That being said, the game engine doesn't have to be always a separate application or software or development engine. It can be something a bit less than that. It's a collection of libraries or framework on which we can develop. And that's what we are going to take a look at next. Okay, so if we want to do something a bit more simplified and create, for example, game with just a framework. So here I have made a knockoff version of a very old popular mobile game called Flappy Bird, and this time it's a Flippy Bird. Basically the idea is that we have a bird which we are flying through the maze. So on this occasion, basically we have a space bar playing the putting the bird, the yellow circle, up, and the gravity brings it down, and the green circles of squares actually represent the obstacles. If we hit an obstacle, our bird dies and we need to start over. So basically, and we get scored based on how long we get on the maze. Basically, fairly simple game and very easy example. In fact, easy enough that I didn't bother to actually draw graphics for it. So how is this a game engine game, or what sort of a background system is this game using? So this is the entire source code of the Flippy Bird I just showed you. So basically what we have here is that we invoke a game engine library called Phaser here and basically create a new object, which is a JavaScript object which will be played in its own canvas for which we set up a game area. If you look at the Phaser itself, it looks like this. Of course, this is being minimized, but still, this is the entire game engine. All the source code or anything that there ever will be in the system is compressed here into about 640,000 characters. So the entire game engine and everything we do or can do with the Phaser game development framework is here in these 647,000 characters. But that doesn't actually mean that it's not as good for our purposes than anything else. Because if we look at what we can do with this framework, of course we make a new game area or new project. We load up the assets similar to what we do in Unity, or which we can do with the Game Maker Studio. Here we load up the bird and the pipe and the background color, well, which could also be a background image, and basically making a set of assets. Then we add the bird into the playing ground, set up the physics engine, set up the game rules, set up how the map is created, and also set up how we can keep score. Then the game runs with these functions, and if we overlap the bird with the pipes, the bird hits the pipes and you die, you get your high score, and the game starts over. So basically, and we have a system which we can use then to reset the state and restart the game and do the other activities. So basically, what we have here is a completely functional game. We have potential for sound effects. Of course, this example didn't have them, but the phaser actually supports them. We have the sprites, we have the characters, we have the enemies, we have behavior with the bird going up and down, up with the player interaction and down with the gravity and the physics engine. We have randomized maps and basically all the other activities we could expect the game engine to do. Only that we have some requirements or some different ways on how we can use this environment to develop our stuff. But everything we need for a game engine or game development framework is here. We have the initialization of the project, we have the loading of the assets, we have the definitions of how the game logic works, we have the ways to keep score, we have actions on what will happen when we do something. For example, here we add velocity to the birds pretty similarly than we would do or actually do in the Unity game engine, and the other ones are also things we actually see also in the more sophisticated and full development engine systems. In fact, if we take a look of another physics engine which is used, for example, in the DI Hunter 2, which you can check out from the grip pages, which I put the link on the previous slide. Basically, this is the same thing, or this is basically a management part of the physics engine of that game, and it's really simplified. It's really simple. It uses different functions to make all the necessary calculations so that our box 2D physics work and are usable, so that we don't have to take care of anything related to physics. This one does that, and we can focus on just making our character go left, right, and jump up from platform to platform. So basically, this also is a framework which allows us to do things, and the phaser, which is a much larger thing, compressed here on its entire source code, is actually something that enables us to develop games. This is a pretty low level thing. I mean, the game engines from the Unity and Unreal, they are development environments. Game Maker Studio and, for example, RPG Maker are more specialized things which enable to start with the lower level of programming knowledge. But of course, these ones are basically additional sets of things you can do which enable you to do games when you know how to do programming work. Of course, there is even lower level where we ditch the entire game engine, and basically this just removes the phaser or the box 2D from your product. You just need to define and write the physics engine yourself, and if you are doing something more complicated with 3D, how the different objects are framed, or how the camera works, or what is drawn on the screen, and how the ray tracing and these things work. So basically, of course, you need to know many other things, but that doesn't necessarily make it completely difficult. And this I will be demonstrating you on my last example, which is coming up next. Okay, so the last option, obviously, we are going to be talking about today is actually developing a game completely without an engine. This, of course, is not impossible because only thing the game engine actually does is to allow the player character to move around the map, loads the maps, shows the textures, shows the 3D objects, plays the enemy AI, sound effects and stuff like that. So here we have an example game which basically is doing all this. This is even simplified version from the Flippy Bird in a sense that this doesn't use any background framework. This is just a very lightweight custom-made 3D engine using JavaScript. So DevOps with a shotgun. So we have effects, we have a map, we have even a mini-map, and we have a person moving around in the work environment. That we are trying to solve. Well, like the shotgun, but anyway, and we have a thing that we are solving tickets and we are aiming for projects. Now we are doing a body and of course every time we do a task, get updated mini-map. Also later so we know whether these or tasks are up. And if we run out of sanity, we run out of alignment and project ends. So this brings us to the end screen, which cycles back to the start screen. So basically an entire game written completely without any framework. So of course this is possible. We have textures, we have a player character, we have enemies, we have enemy AI. They can move around and they are basically hunting us. We have some power-ups, we have ways of measuring things. But in general, this is just an example that yes, you can do game development without the framework. This was something that was tailored by me from a hackathon or game jam demonstration. I don't remember where I based this on, but anyway, just to show you that of course if you are interested in learning all the insights and what happens inside the game engine and how to get all the power out from your system, you can also work without the game engines. Although that being said, basically all the game studios use game engines exactly for the reason because it's easier to get things done and manage things, and of course it allows the game developer team to have people who don't necessarily have that high skills in programming to participate and do meaningful work, for example on the level design or setting up the game logics or doing something else like testing out that the graphics actually work, the animations work, and that the entire overall theme is something that fits together.
So I showed you 5 different examples and 4 different games on games engines of different size and variety. So you have seen, or I have shown that there's different things related to game engines, and what the game engines do and don't do depends on what type of game engine you want to select for your course. So of course on this course the idea is not just to learn to use one game engine. We could have done this course purely as a Unity 3D course. We could have done this purely as an Unreal Engine course or a Game Maker course. The idea is not to learn how to use one game engine. The idea is that you get to understand how software development and game development differ from each other. And for example, in this case, how these levels and animations and objects and scripts and sound effects and music, how they are tailored together into a product we know as games. And of course, you can do this with the game engine or without the game engine, as demonstrated. But usually the game engines makes it easier to manage the versions or allow several people to work on the project at the same time, and also takes away the heavy lifting of the background work, building the visual presentations or the camera work or the rendering work of how things are drawn on the screen. If you want to take a look at that part, then you have to start learning OpenGL or this driver framework programming, which is a completely different beast. Of course, it would be prudent to say that you should pick one game engine and learn how to use that. And while this is a good idea, you also need or should learn a couple of other things, but this is something that we are going to be talking about on our next lecture, which will be talking about how to run a game studio or how game studios run and what sort of technical expertise besides the obvious able to use game engines is usually required. So, like said on the start of the lecture, we are now at the midpoint schedule-wise. This is the third lecture out of the 6 lectures if we count also in the visiting lecturer. And of course, if you are following this course on the normal schedule, this is also the end of the first period, and after the exam week, the second period will start. Of course, you still have plenty of time to get everything done, but if you were evenly distributing things out, about now you should be done with your project 1, the tutorials, and you should have an idea on what your own game will be, so that latest after today's presentation you know what game engine you will be using, what sort of assets that game engine eats, what sort of graphics, sound effects, stuff you will need to gather around or make yourself, and in general have your own game idea and game design document done. Also, remember that we have the weekly advice sessions with the teaching assistant, and you are always free and to ask questions or help from this course's Moodle pages. Okay, so this is the small crash course into different types of game engines. As said earlier, the course is now at its midpoint. So if you are doing this on schedule, you now should be in stage where you are about done with the tutorials and already know what type of game you are doing. If you are still lagging a bit behind, it's not that big of a concern. There's still plenty of time to catch up, but please keep in mind that within 1 month or so we will be starting the peer reviews and your game should be up and running by then. In any case, if you are following this course on normal fall semester, the next week is probably going to be an exam and holiday week. So have a nice relaxing holiday if you can do that. And if you have exams, well, then you take the days off and hopefully you will have a relaxing holidays after you have completed your responsibilities and exams. And we will see again in the second period when we will be continuing with the theme of how game startups or game business differs from the actual software companies and software developing organizations. But until then, have a relaxing holiday if you have one, and have fun. That's part of the part of this course, to make games, have fun, and have an entertaining projects which you hopefully also find interesting. So goodbye and see you next time.